survive. Hello and good day, Algebra. We are going over CO10, which is the first of 5 rules that we're going to be learning about for simplifying exponent expressions. Okay, simplifying exponent expressions. Expanded form is gonna make a cameo appearance here because we're going to use expanded form to explain why the rules work. Okay, but ultimately the rules are what you should be putting on a help sheet. I've got every objective as something similar to this. We're going to talk about what happens to the coefficients, what happens to the exponents, what happens to the bases when we're doing these various things. And when we talk about simplifying in the terms of exponents, to simplify means to combine terms with like bases. I put 2 lines, so I better use them. Combine terms with like bases. Thus, why it's important to know what a base is versus a coefficient or an exponent. Okay? And we're going to start by looking at this through the lens of expanded form. It says, consider the expressions below. First, write each in expanded form. And then, ultimately, what can be combined so that the expanded form version is just one term. So, 3 to the 4th times 3. What's 3 to the 4th in expanded form? Nathan.
3 times 3 times 3 times 3 and...
Yeah. So the 3 to the 4th term is 3 times 3 times 3 times 3. Right? And then we're multiplying that by another 3. Really, how many 3's do we have all being multiplied together here? Whiteford? 5. So what would the term be using an exponent, Jocelyn? 3 to the 5th. So the expression 3 to the 4th times 3 can be simplified to be 3 to the 5th. And we can do this because the base of our 3 to the 4th is the same as the base in 3 to the, if there's no exponent written, 3 to the 1st. Another one of those hidden ones that'll pop up sporadically here, right? Just a 3 by itself is like 3 to the 1st. So we got 4 3's all being multiplied together times one more 3 total. That's 5 of them. 3 to the 5th. Okay. Our next one. What's the base? Raise your hand, please. What's the base of 7y cubed? Paul, because I asked. What's the base? Dad joke. I'm sorry. Okay. You're right. The base is y here, right? Which is the same as the base in y to the 4th. So these can be combined because they have like bases. What is 7y cubed in expanded form? Andrea. 7 times y times y times y. That 7's a coefficient. There's only one of them. No parentheses here, right? So 7 times y times y times y. And we're multiplying that by our second term, which is what in expanded form? Paul. Y times y times y times y. Who can tell me an easier way to write that long expression using an exponent? Cole, is that a hand up?
Yes. Is it 7y to the 7th?
It is. 7y to the 7th power. Right? Because we got 7 y's all being multiplied together. That's what an exponent's used for, right? To show how many of something's being multiplied together. Okay, that's fun. How about the last one here? The first one, 8xy squared. First time we've seen 2 variables in the same expression. That's okay. We can handle this. What is 8xy squared in expanded form? What do you think? What do you think, Jocelyn? Ooh. Okay. Oh, so you went on to okay. Yeah, so 8xy squared, there's only one x there, right? It's x to the 1st. We don't write the 1, but it's there. So 1, 8, 1x, and then y times y. And that second expression, we do have that coefficient 5 out in front also, but we do have x squared, which is x times x, and then y cubed, which is y times y times y. Whew. Maddie, put it all together for us. What do we got? Okay, so total, how many x's do we have? We've got 3 of them, right? And the beauty of, multiplication is what? Kaylin? Right, you can multiply things in any order. So even though these x's aren't next to each other, that's okay. We still have 3 of them, x cubed. Even though those y's aren't next to each other, that's okay. We still have a total of 5 of them, y to the 5th. Why is my marker getting all... That's weird. Okay. But then what's my coefficient out in front here? What's my coefficient, Colin? 40. Just like we can move those x's around and put them together, we can put our coefficients together also, and we do that with multiplication. So 40x cubed y to the 5th would be our simplified expression. Okay. Now, as much fun as writing this out in expanded form would be every single time, eventually our hands would get kind of tired. Okay. So if we can come up with some sort of pattern, some sort of rule that we can use whenever we multiply by the same base, that's going to make this process more efficient and faster, it's going to be to our benefit. We can see why we can do this with expanded form, but what are you noticing? Does anything stand out to you looking at what our original expressions are and our final combined answer? What do you see? What do you see? Caitlin. Okay, so our exponents here, we can see it here pretty easily. We have a 3 and a 4. Our final answer exponent was a 7. 3 plus 4 is 7. And we can see why that works too, because if we have 3 of them, we get 4 more. Total, we've got 7, right? In the second one, our y's, we'll start with that one. 2 and 3. Our final exponent's 5. Plus 3 is 5. And with those x's, we have 2 here, and there's that hidden 1, right? And 2 plus 1 gives us 3. Same thing here. 3 to the 4th, 3 to the 1st, 3 plus 1 is 5. Excellent. Okay? So the exponents, when multiplying by the same base, are added. Okay? When multiplying by the same base, exponents are added. What about the coefficients? And there's really only one with 2 true coefficients, number 3 there. But what do we do there, Colin? We multiply them. As we explained earlier, because you can multiply these things in any order. Okay, it doesn't matter the 8 and the 5 aren't next to each other. They combine to give us 40. So with this rule, the exponents are multiplied. Coefficients, sorry, thank you. Coefficients are multiplied. And really, in that second one too, the hidden coefficient to this y term here is a 1, right? All these hidden 1s everywhere. But 7 times 1 still gives us 7 as a coefficient here, so it still works out there. And then how about the base? What happens to the base? In the first one, our bases were 3, and we ended up with a 3. Second one, our bases y, we ended up with a y. Last one, our bases of x, still have an x. Our bases of y, still have a y. What happens to the bases when we multiply by the same base? Yeah, Nathan? They stay the same. Your base does not change. Okay? The most common error that people make with this rule actually happens with the bases. And it's a question such as this where your base is a number. Can you guess what the most common incorrect answer this would be, Andrea? For the 3 to the 4th times 3? 9 to the 5th. Yeah, people want to multiply those bases because they're thinking coefficients, because coefficients are always numbers, right? But because bases can be numbers, you need to understand the difference between a coefficient and a base. Because 9 to the 5th is not the correct answer. as expanded form proved to us, right? There were no 9s in there. They were all 3s, okay? So watch out for that, okay? Pay attention to what's a base and what is a coefficient. Questions? Isn't this fun, by the way? Isn't this good stuff? This is new to probably most of you. You've done exponents before, but probably not this way. So whereas Unit 1 was a lot of review stuff, Unit 2 is going to be new for most people, I would think. All right? Questions on this, though, so far? Okay. Let's work through a few of them in the second section. I am requiring you to write this in expanded form to start, just so we get practice with it. Go ahead, glare at me, roll your eyes, whatever you want to do. But it's worth it to understand what's really going on here. So of these 8 that are up here, who's got one that looks particularly inviting or complicated you want to talk about together? Maddie? Or just fun? Yeah. Sure. 14x times 10x to the 5th. So in expanded form, we do need to write out that 14x is 14 times x. If you want to put x to the first, just to remind you it's got a power of 1, go ahead and do it. Okay? Because it is there. We do have to consider it. And then we're multiplying that by 10x to the 5th, which is 110 and then 5 x's. Okay? I guess really, if you're good with the power of 1, you do it on your original expression, not the expanded form. But either way, whatever. And what do we get as a simplified term here? Let's get a new voice, perhaps. Something we have not heard from yet today. A new contributor to the channel. Tristan. 140x to the 6th power. Making sure you include that base. Okay. 140x to the 6th. Good. Any others you want to go over? Yeah.
Can you do the last one?
Sure. It is a fun one. 1/2 a to the 5th is 1/2. Coefficients can be fractions. Nothing wrong with that. So 1/2 times a times a times a times a times a. And we're multiplying that by 200, a squared. Okay. And so we look at what we can combine here. We consider our rule. Coefficients are multiplied. Our coefficients here are 1/2 and 200. The brain doesn't like to think about 1/2 times 200. It much prefers to think about it as 1/2 of 200, because remember that word of means that you multiply. When I phrase it as 1/2 of 200, you're, oh yeah, duh. 33 people in the room know what the answer is. What is 1/2 of 200? Chase? 100, right? Which is what 1/2 times 200 is also, but the brain likes the word of when it comes to fractions a little bit better. So 100 is our coefficient. How many a's do we have total? We've got 7 of them, which we can see when we add those powers up above. 5 plus 2 gives us 7. I love rules so much. Didn't like to follow them when I was a kid, but I love them now. Any others from this first page you want to go over? Okay. The point of these first 8 is for you to really see how expanded form can help you, how expanded form works. Yeah. Yeah, so those first 2 are those common mistake ones. You're not going to get 36 here because 6 is a base. It's not a coefficient, right? And you can see that in expanded form. 6 squared is 6 times 6. 6 cubed, 6 times 6 times 6. There aren't any 36s in there, right? You have 5 6s all being multiplied together, not 5 36s. Okay, so expanded form can really be a good tool to understand why that base stays the same. For that one, and why you do not multiply 6 and 6, because they're not coefficients, they're bases. Same thing with the next one. When you put in expanded form, you got 5 10s, not 5 100s, right? So 10 to the 5th. Okay. Others? All right. The next page will be your homework for tomorrow, in addition to finishing this here. But it says simplify each expression. The goal here is to not have to write the expression in expanded form. Take a look at some of the powers that you have here. You have an 11, you have 8, 9, and 3, and 1 all the same thing. Down the bottom here, you got x to the 10th, y to the 13th. We don't want to have to write it in expanded form every single time. So this is where we use the rule, right? So you don't have to write this in expanded form. I encourage you not to. I want you to use the rule instead. You did expanded form on the front side. Now we use the rule. Eli. You do not need to show work here. Okay? Do not need to show work here. Which I know opens the door for shortcuts. But remember, you don't learn anything with shortcuts. A shortcut on homework is a shortcut to your understanding as well. Put in the time now to learn it so that you understand the shortcut, right? And then use it to your full advantage. Nick. It's due tomorrow. Due tomorrow. Nathan. Okay. Good. Down at the very bottom, you kind of use the rule backwards. You need to fill in the missing powers. That first one there, n to the something times n to the 5th equals n to the 11th. What does the n to the something have to be for this rule to work out? Eli, got to be a 6, right? Because if our total number of n's is 11, you already know you've got 5 of them. That means this has got to be a 6. 6 plus 5 is 11. So we kind of think about the rule backwards for that bottom section there. Okay. Any from this that you want to go over, as long as we've got the time here? A couple minutes. What's that? You've got about 2 minutes left. You're already done. Wow. Okay. Good. Any? None? You're all. Be prepared for the homework check tomorrow. Okay. There'll be 5 questions from this page. And don't forget to finish the front side also. The first page that we only did a half of them, but that is homework for tomorrow as well. Okay, if that's all you've got, that's all I've got, that's how you math.
Don't forget to like.